The vertices of square KLMN are K is given there 1 1, L 1 3, M 3 3, N 3 1. The vertices of its image under transformation T are K prime 1 negative 2, L prime 1 negative 6, M prime 3 negative 6, and N prime 3 negative 2. On the grid provided, draw KLMN and its image K prime, L prime, M prime, N prime under T. So the first question is just to draw. You draw these two. So I've written the coordinates here. So let's draw them. K11. So K11. K11 is them. So this is K. Then L13. M33. And then N31. N31. So you have the position there. So you have K is there, L is there, M is there, N is there. So join them. Join them. Like that. So you've joined. Then you have K prime. K prime is here. K prime is 1 negative 2. 1 negative 2. L prime 1 negative 6. M prime 3 negative 6. And then we have N prime 3 negative 2. So we've done that. So let us join the points. So those are the points. So the other was there. Let me put it properly so that you can see it. Like that. So that is the first question. The first question you simply require to the grid provide draw KLMN and its image under T, the transformation T. Then part 2, determine the matrix of transformation represented by T. So for T, you don't know that matrix, but you have the object and the image. So what you do in that question, you simply let the matrix T be represented by A, B, C, and D. So in order to get that T, you simply pre-multiply by the object, that is A, B, C, D. Then K so you have K so you have K. So pre-multiply the object, which is K, L, M, N, with the matrix ABCD, which is T. So this is you have it here. K is 1 1. So 1 1. And then we have 1 3 3 3. So this is 1 3. You have 3 3. And then you have n, and is 31. Is equals to, now you have the image that is K prime, L prime, M prime, N prime. That we have them here. So you have 1, negative 2, 1, negative 2, and then L is 1, negative 6, 3, negative 6, and N you have 3, negative 2. Now after doing that, now you don't need to multiply everything, so you're going to just multiply up to this point. Let me guide you here. Up to this point, that is why you're going to multiply. You don't need all of them for you to get A, B, C, and D. So this is what you're going to do. And also for this one, we can multiply up that point. That will be still okay. Now this is how we multiply it. So row 1, column 1, so this will be A plus. So row 1, column 1, we have A plus B, A plus B. So we have A plus B. Then row 1, column 2 will be A plus 3B. Row 2, column 1, C plus D. Then row 2, column 2 will be C plus 3D. So you can see I've used only the two K and L is equals to K and L. This is K prime, L prime. So these will be 1, negative 2, 1, negative 6. Those two are enough because you're going to use them to form simultaneous equations, and this is how you do it. So you take A plus B is equals to 1. And then you take A plus 3B. A plus 3B is equals to 1. So you can eliminate these, use elimination, subtract. A will be eliminated, so you have minus 2B, B minus 3B minus 2B is equals to 0. So for this case, you get B to be 0. And if B is equals to 0, if you substitute here A plus B is equals to 1, you'll get A to be 1. So you can see that one as given as A and B. So that is given as A and B. So now we can proceed and use the other one to get C and D. So C plus D is equals to negative 2. And then C plus 3D is equals to negative 6. So again, you can subtract this to eliminate C. This D minus 3D will give minus 2D is equals to negative 2. Subtract negative 6, that will be negative 2 plus 6, that will be 4. And for this one, D will be negative 2, like that. So if D is negative 2, if you substitute in this equation here, we substitute here, when D is negative 2, you'll get C to be 0. Just substitute D here with negative 2, and you get C to be 0. Now you have A is there, B is there, C is there, and D is there. So A, B, C, D, which is the required matrix, that is T, that is matrix T, will be given by A is 1, B is 0, C is 0, and D is negative 2. So that is the matrix T that is required. So that is how we do it. Now the next question is here. Find the vertices K double prime, L double prime, M double prime, N double prime, the image of K, L, M, N, and a transformation represented by U. On the same grid, draw it. Supposed to draw it. So you have this matrix U that is transforming. So we have 1, 0, negative 3, and 1. This matrix is transforming K, L, M, N, K, L, M, N, K, L, M, N. Remember, K, L, M, N is there, of coordinates there, given there. So we can read them there, K, L, M, N. and it is transforming that to give K double prime. So we need to get that. We need to get the coordinates of that. Need to get the coordinates of that. So let me check here. It is okay. So K is 1 1. This is 1 1. This one is 1 3. M is 3 3 3 1. This is a 3 3 3 1, like that. So now this one is transforming this one to K double prime, L double prime, M double prime, and N double prime, like that. So let's get the image, and then from there we can plot it. So row 1, column 1. So this is 1. This will give us 1, subtract 3, so that will give -2. And then this is a 1, subtract 9, that will be -8. Then this is a 1, this is a 3, subtract 3, this will be 3. Let me look at it again. So it will be 3, subtract 9, that will be -6. Seen it? And then N, this is a 3, subtract 3, that will be 0. I'm through with the row 1. It is my assumption that you're able to multiply the matrices. So row 2, column 1, this will be easy. This will be, when you multiply row 2 times all these column 1, this will give 1. Then this will give 3, this will give 3, and then this one will give 1, like that. So ensure that before you able to come to matrices, you have practiced on how to multiply matrices, because that is not the main concept in this question. Ensure that you're able to multiply matrices very well. Now we have the image, so we can plot it. So -2 1. So we have -2 1. -2 1, it is there. That is K double prime. And then we have -8 3. -8 3. That is L double prime. And then we have -6 3. -6 3. M double prime. And then N 0 1. 0. And this is 0 1. 0 1 is here. N double prime. So we can join these. So K to L, like that, and then M. Increase this width, so we have that, joining the point, and that, and then we have up to that point, and then there we have it. So we've done that part. So we're through with plotting. So we've drawn it. So from there, we are supposed to describe that transformation fully. Describe the transformation fully. So let us look at these two, KLMN. Is here, KLMN, and then the image. So which type of transformation is that? When you just look at that transformation, you notice that this one is a shear. And why do you conclude that this one is a shear? What points make you to think that this one is a shear? Because you can see the points are displaced parallel to a certain fixed line. That is number one. You can see all the points are shifting parallel to a certain line. Look at M and M prime. Look at M and M prime. Look at L, L prime. Look at N, N prime. Look at K, K prime there. So the points are shifting parallel to a given fixed line. That is one. Then look at the shape. The shape is distorted. So which kind of transformation is this? And that is where you conclude that this one is a shear. It is the one that has those properties. The one which is very important is that the points are shifting parallel to a certain fixed line. So now, after identifying that one is shear, how do you describe a shear fully? Number one, by giving the shear factor. By giving the shear factor, that is the first one. And how do you give the shear factor? You give the shear factor, I'll write it here. You give the shear factor by getting the displacement. So you simply get the displacement of a point, of an object point to the image point. In this case, you can take displacement from, let's say, L to L double prime, and then we divide by the perpendicular distance of object, of the object or image. It can be object or image from the invariant line. From the invariant line. So that is how you get the shear factor. Now, I've mentioned the invariant line. How do you identify the invariant line? So look at these points here. To get the invariant line, also there is a way you do it. So invariant line, if you want to get it, you simply take the image distance, let's say L double prime, K double prime, extend that line to join with L, K. So in the diagram, I'll do that. So L, K, so L double prime. So let me join it so that I can show you how you get that. So join L double prime, K double prime, and ensure that you extend it fully. You extend it fully like that. That is the line L double prime, K double prime. Then the other line LK is here, and you extend it. Where are the two lines meeting? So look at those two lines. Look at those two lines. So L double prime, K double prime, and LK. I've started by drawing L double prime, K double prime, extending it. Then LK, extending it. Where do they meet? The two are supposed to meet on the invariant line. They're meeting here, and they're meeting on the invariant line. So the invariant line here is the x-axis. These points are shifting parallel to the invariant line. Look at M and look at M prime. They're shifting parallel to the invariant line. So the invariant line is where these two lines are meeting. The invariant line is there for the x-axis. So invariant line, in this case, invariant line is the x-axis. So now let's get the shear factor using that now. So the shear factor is, look at the displacement L to L double prime. So count the number of squares from L to L double prime. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 squares to the left. From L to L double prime, there are 9 squares. So because it is to the left, going to the negative axis, you write it as -9. Because you can see the image is shifted to the negative part of the axis. Then the perpendicular distance of object point to the invariant line. So I'll pick the object point to be, let's say, L. So what is the perpendicular distance of L to the invariant line? So from L, count the distance, count these as squares. So they're 1, 2, 3. There are 3 squares from L to the invariant line. So that is what we mean. Perpendicular distance of the object point or the image point. So use the object point like L to the invariant line. Count the number of Squares 1, 2, 3. So there are 3 squares. So these will be divided by 3. So the shear factor is -3. Now to describe that fully to describe the shear fully, this is what you do. So you say that this is a shear with scale factor being -3 and x-axis as the invariant line. You are describing now a shear fully by stating the shear factor invariant line, and then you have to give the object point and the image point. Let's say I'll pick L and L double prime. So L, which is 1, 3, L 1, 3 is mapped onto L double prime. That is mapped onto L double prime. We noted that one was what? That was -8, 3. -8, 3. So -8, 3. -8, 3. By doing so, you have described the shear fully. State that shear factor, the invariant line, and then you give the object point and the image point.